very good advantage. This advantage is very, very representative and till today it is valid because it is very easy. Major advantage is for a large log mass characterization, you need to have a less amount of input. For whole characterization, you need large amount of input data set. But for this classification system, you need less input data set. So with this least input data set, you can start your work. Your work will proceed. The disadvantage is it cannot be used everywhere. That is why Professor Gassil also told that people have used different classification system blindly, and that is why different errors are occurred. So you need to take care of which type of specific cases is useful for this kind of classification system. So this is basically the precaution before we are going to discuss different type of block classification system. So the process, how proper, suppose if we question a scientist who are working in the development of a new classification system, they generally follow this kind of procedure. This is more or less the abstract or a summary of the approach. Suppose they have to they have to see the observation. This observation will be everywhere. I have also dealt in the first class. This observation in rock mechanics is very, very important. So after observation, you need to induct the observation. There is some logic, inductive logic, deductive logic. Generally follow this type of logic is developed for last 2 millennia. People have developed different ideas based on this logic system. So based on this logic system, you deduce there is some general observation. From that general observation, you conclude something. Based on that, you have to test. Okay, if the gap aperture is more in the joint, I saw that there is large amount of fluid flow. So I am predicting. Then I have to test in my laboratory whether with the aperture my observation is correct. So it is hypothesis first. Then if it is been tested in the laboratory, then it is correct observation. You can take it back. So this way, it is a summary approach for development of this kind of empirical system. Every kind of empirical system, what is practiced globally. It is not visible very clearly. This is basically actually showing you the different advent or evolution of different classification system. In detail, you can see this. Journey started from 1946 by Tarjani. He proposed a classification system based on rock load and application to tunnels. And now today ending here in 2014, rock mass quality rating system. And still there is a scope of development. If you go through different reports of different countries, they have inducted different kind of classification system based on the requirement. I have gone through while preparing the reports some study in Sri Lanka. They have approached newly to classify their rock mass for developing tunnels. So based on the requirement, they have thought of procedural approach and they have come out with a new classification system. So for India also it is equally applicable. I will give you one supplementary material. The monograph is developed by Central Soil Research Station. Most probably it is a New Delhi Government of India organization. I will give you the material. And that is basically most of the material is available there. Majority. This is basically the process I am talking about. This kind of flowchart we need to take care of. In detail, we have to test in different kind of system. Nowadays, due to the facility of the development of the numerical methods, you can also implement equally numerical methods with the rock classification system. Whether it can collaborate well or whether it is not collaborate. So based on the computational facility available now, you can thought of clubbing together rock mass classification system with the new advent of new elements. I will cite you two papers, though they are using now artificial intelligence also, machine learning also, for fine tuning the approach being practiced for last 40 years. Now, why actually we are looking after the classification system? To know the ground interaction. Because when we want to work with the rock, we need to interact with the rock. We may drive tunnels, we may fracture something for petroleum exploration purpose, hydrofracturing. For mining, we have to drive a gallery. For open pit, we need to extract. So, based on different requirement, whether small scale or large scale, we need to interact with the rock. So, rock will behave differently based on its characteristics. If the joint pattern is favorable, then you need to take care of something. If joint pattern is not favorable, you think about the other approach. So based on that, basically, your criteria will evolve. Now, if I schematically tell you what kind of precautions, what kind of classification need to be taken care of. Suppose the first system. This is intact rock. Intact rock, basically, if we think about if it is elastic, then as an engineer, I can tell you the rock behavior is known more or less. I can from the graph, if I take a sample in the laboratory, you will test. From the graph, I will tell whether the graph is correct or not even. For a homogeneous rock, suppose a limestone is there, a very good limestone, quality graded limestone, if you test it uniaxial compressive strength or triaxial, from the result we can say as engineer, all engineers can tell it, that whether the graph is correct or not. Because of what? Because we know the characteristics of the intact rock. Because the characteristics of the intact rock up to certain limit behave elastic. So that is the advantage. But if there is a joint, then suppose the first test, if there is a joint, then we need to take care of other weight. Might be the triaxial test is not sufficient because there is a joint. So if there is a joint, we need to take care of what is the shear strength of the joint. So based on the alignment of the joint plane, we need to take care of the sample preparation so that the joint will come into the middle, so that I can test in my apparatus. So for that, engineering judgment is very, very necessary. Those who are pouring the rock, they need to take care of that thing, so that joint is aligned in the middle and parallel to the flattened surface. Because you have to test in direct shear, and you have to shear the material so that you can find out what amount of resistance being offered by that joint plane. So it is possible for a one joint set. If it is a multiple joint set, suppose the third one, multiple joint set, then the complexity comes to a situation where you cannot handle in simple laboratory testing. That is why classification system is very, very useful in this kind of system. Up to this stage, your test is sufficient, and you can also model pretty well using numerical models, and it can be 100% more or less fit or 99%. But after this, you don't know what could be the possible behavior. The last, if the material is heavily jointed, then the performance, behavior, response is more or less similar to the soil. Means it is highly porous, high chance of water table, and that is what happened recently, whether you are aware of it or not. In Calcutta, in metro project, there is a devassation. In the underground metro near Bowbazar, there is a inundation, and more than 100 building collapsed. What is the reason? Possible reason? Possible reason is this, that when the tunnel is driving at 33 meter or feet, I doubt it is possibly 33 meter, when it is going through, they have interacted with the sandstone layer. That sandstone layer is a very porous, and there is a local water table that could not be predicted earlier. So within a few hours, there is a large amount of ingress of water, and in the surface for a 1 square kilometer area, more than 100 building collapse. Luckily, there is no fatality. Later on, people died due to the depression because their building is collapsed. There is no rehabilitation, so that is a separate matter. But due to the accident, 100 number of buildings will collapse. So, very porous rock layer is very traceable for the engineers to design, and particularly metro project like in city where the residential complex is there. So for this kind of rock, might be a rock classification system will not work. A rigorous amount of testing and modeling need to be taken care of otherwise. Now going to suppose analytically, if we think about the first case, low stress level and it is a massive log, there is no discontinuity, you can model, no problem. Second one, high stress level but massive rock, it is also able, you can predict using your numerical method as well as elastic approach what is available. But for other cases, heavily jointed one, it is very difficult. These two cases. That is why here also, what I propose you in the last class, physical modeling and synthetic kind of material modeling might be very well. And people are thinking about this also in future course of action. Heavy amount of computational facility will be available, and they can simulate in the larger scale. Might be physical modeling give a lot of insight about the behavior of this kind of rock. But nowadays, still we are working with this system with the taking care of rock mass classification system. Now, this has already been covered, so I will briefly go through. A rock will behave differently based on the presence of joint set. If it is a one joint set, this is the response. If it is a two joint set, then there is this kind of response. If it is a multiple joint set, response is more or less one. So heavily joined set rock can be categorized in the soil category. Intact rock is intact rock. In the middle, you need to take care. So like that. This is the sample, this is the test, and this kind of anisotropy is observed in ion modulus also, intact rock as well as the disturbed rock. Now, engineering rock mass classification need to be taken care of. What are the objectives you are going to set forth, and what kind of parameters you are going to take care of, and that will, this last one is very important. It is very project specific. It is very project specific. Based on that project, it is, you can apply up to 10%, 15% statistical variance. Same thing you cannot apply in the other project. So that is one of the major limitations in this kind of system. Tarjagi, when they developed this concept, they have thought of this kind of parameters. What parameters they think of? Intact, stratified, moderately joined, blocky, seamy, grass, squeezing, swelling. But for your information, I can tell you, after this grass, squeezing, swelling, still not been addressed at 2019. They have thought of in 1946 that this kind of character of rock can be taken care of in rock classification system, but till date it is not been achieved. It is not been achieved because of different complexity. I have already told you it is very inhomogeneous, so it is very non-linear. So no, basically all this classification system is one way is a linear approach. Basically you are scaling down the complexity to a simple one. That is why heavily non-linear kind of things cannot be taken. Though they have thought of it, that they can take care of it. So this is the description. I don't think it is very much required. You will get this material and you can read it. I am skipping. These two parameters most probably you are aware of in those who are basically in civil engineering: squeezing and swelling. Squeezing and swelling is a very problematic soil we are facing in Indian different part of location. Particularly the swelling factor we have faced particularly when we work in Western Coalfield Limiteds. It is a very dangerous soil. So when my third lecture will be, we will try to deal with in detail in slope stability. In this process, Diri et al. Developed a concept of quality designation. This basically a very helpful approach. Very helpful approach. This RQD to characterize law. Very helpful. In a one word, if you ask me the advantage a lot. RQD will tell many things about the quality of the rock, really. Because RQD taken care of more than 10 centimeter core into the consideration, and they sum it into the total recovery, total drill core length, and if it is 90% or 85%, then it is good. The conception is, what is the philosophy then again? If we think about it, I am coming this later. Think about this. This is the rock core. Different rock core from different places. You see, minimally, there is some drill core, longer length, there is small, then again longer, like that. See this? It is basically all are small one. This indicates what? This basically indicates that there is a large population of joint set. Large population of the joint set means it is heavily jointed parallelly. So if we orient your tunnel or underground driveway or roadway, you need to take care of this kind of parallel orientation of the joint. So RQD basically tells you about the idea. Not only the facilities, one advantage in RQD is when a drill core recovery is going on, an experienced driller can experience many things. What happens? Suppose a drill core is run in this place. When drill core is running, suddenly when there is a discontinuity, driller will experience more rate of advancement of the drill rod. So what experienced driller takes care of at that particular time, suppose at 9 am they have started, at 9:11 56 second time they observe this kind of, so they take notes of it and they actually supply these notes for the geologists to consider when they will determine the RQD, because that will help also to accurately predict and pinpoint the location and the position of the joint set in the drill core. So the finally RQD actually tells you the population of the joint set present in the drill core. But might be there is one problem. Suppose you have drilled the core in such a way that in between two joint set it is been perforated, it is been drilled. So no joint been observed. So this is another limitation, disadvantage of this kind of system. So before drilling, from the surface outcrop you have to predict in which direction you will drill, so that a large amount of joint set you can capture. So this is basically also based on the experience. Good engineer, good geologist can guide you which direction you will drill to recover. So it is also very subjective, so you need to take care of in future when you will consider this kind of parameter in the field. So in the literature, if you find, RQT have used for many purposes for characterizing the rock quality. Suppose in Palstrom in 1980 they have used RQT with the joint discontinuity per unit volume, a criteria empirical approach though they have developed. Hudson in 1976 they have come out with joint frequency kind of parameters, and it is pretty matching. I should move fast. This is already been dealt in different way by Vasily. Basically, what is it basically telling? It's telling you the block size and different categories of joint set in a rock mass. So suppose your responsibility is to take care of all this total rock domain and to classify it. What would be your possible approach? You will try to accommodate all the joint set in your conception, in your concept development strategy, and not only that, you have to think about the discontinuity patterns, discontinuity qualities, how rough it is, how much ripple is there, these kind of things you will take care of. So to do that, different classification system being proposed. One of the major renowned rock category classification system is rock mass rating system. And in 2004, last modification been incorporated, and it is still going on. That is why I am telling you it is still today it is useful, because based on different experience, different engineers, different geomechanics group actually improve the different deficiencies present in this rock mass rating system, and they are improving. They are actually rectifying their errors and coming out with good and better classification system. So RMR is still in the phase of modification. It is going on modification and it is improving. The quality of this rating is improving. This tunneling index, you know, pattern is proposed. And another, in RMR rating system, people have thought of using the geological strength index criteria to classify different quantities of rock. This is very simple approach. I will skip only for information. Rock structure rating was one kind of rating system in developed, and basically 3 parameters is there, and addition of all this actually representing the structure rating. They have also proposed some table that might be useful for you also. I am skipping based on different direction, whether it is perpendicularly aligned or parallelly aligned. They have assigned some value in different categories, and then coming up with the consideration of rock structure rating. And they try to correlate the rock structure rating on what should be the diameter of tunnel, and they have tried to model whether it is fitting well, and up to certain limit definitely it will result in different complexities in different conditions, might not work. That is why this kind of classification system is no more in use. Then the most discussed and most studied classification system in mining, civil, geologist is rock mass rating system developed by UNISCO in 1976. They have considered, see the decision they have taken care of to consider the parameters. They have considered uniaxial compressive strength of the rock, consider RQT, joint spacing, not joint spacing, spacing of the discontinuity, condition of the discontinuity, groundwater condition, and orientation of the discontinuity. Okay, and this is again project specific. So in all classification system you need to take care of this note that this classification system have a limitation on the side to side it will vary. See the changes for the RMR system in different epoch, different areas. Same value they are assigning separate rating, because I am telling you they are in the process of rectifying, because each and every parameter, these many parameters actually given some rating. Earlier it was 10 to 15 most probably, it is 20, 15, 20 like that, so total is 100. So they are now fine tuning which parameter should be given more, which parameter should be given less, and it is still today it is important. The latest is mostly used this chart in different A, B, C. You will see in the text I will give you the monograph, you can see that. Here you see the difference, drive in the deep and drive against the deep have a separate category you have to consider. So they have rightly taken care of these things in their classification system. So in a summary, if the rock rating is in the above 80, it is good, and it is really good for your engineering design also. They have taken, there are different development of RMR. There might be, we have thought of RMR 14, RMR 06, RMR 89. Different RMR being developed by different teams, and they have some limitations, some advantage over others. So these are the derived parameters, rock mass strength and deformability, and they have tried to recollect and correlate the RMR into the Young's modulus, into the compressive other strength of the rock, C, phi, like that, and it is working. I am skipping. Now see, people have tried to correlate the RMR to the deformation modulus, and see the fitting of the curve. See the fitting of the curve. It is in different zone, they have different characteristics though, but it is fitting. So this is one kind of advantage of this kind of rating system. So without doing some test, you can pretty well predict the nearby range of the Young's modulus, deformation modulus, based on the RMR. So this is this kind of advantage you are going to get from this kind of classification system. And there are different teams have worked, and it is work going on by different countries, and they are using and they are actually modifying based on different observations side to side how this RMR can be taken care of, and for predicting the modulus or deformation. Because in the last class, when we are discussing about experimental rock mechanics, we generally determine Young's modulus for a intact rock. Remember, we generally determine Young's modulus for intact rock. For a rock mass, determining the Young's modulus in the laboratory is very difficult. So that is why people have thought of, okay, RMR is very useful technique, and it is collaborating well in different field side. Whether this RMR can be back calculated to predict the deformation modulus or not. And they have found, yes, it can be found out up to a pretty good limit. There are different works, different teams have done work. Still in 2019, I have seen a paper. They are trying to correlate the Young's modulus and deformation modulus with the I of the rock mass. tunnel radius, they have lot of the use is how much support system you will use, what should be the diameter based on different RMR rating, and it is what. I am skipping. These are the material you can get it. Last see, this is what I was telling about. In last 2014, people have modified the rating system also. Earlier, intact rock strength was given 10, means 10% influence, weightage. Now it is given 15% weightage. So weightage is increased. So based on that, they have fine-tuned all these parameters. We will go through that. And after that, there are different limitations of the RMR system, particularly in hard rock and very jointed rock in deep tunnels. So people have thought we need to take care of different classification system, and one of the classification system being proposed by Nick Barton and his team. I don't know, most probably 1972 they have proposed. 1972, the oldest model of the Q system. Based on this Scandinavia, they have done their project, and it is basically numerical value on log scale. Another is value varies from 0 to 1000. They consider nicely RQD, joint shape number, joint roughness number, joint toleration number, water reduction factor, and stress reduction factor. But they have not considered joint orientation. See, they have not considered in RQD by GIAN will tell you something. RQD actually representative of joint population set. So GIAN basically joint number, then basically it will tell you the box size, geometrically, logically. Similarly, GR by GA will represent you the roughness or frictional characteristics or shear strength characteristics of the rock mass. And the last J W divided by SRF is basically tells you about the external loading condition due to presence of flow or flow of fluid. So they have not taken care of the joint orientation. So this is one of the major limitation in the Q system, though in different project it is worked fine. These are the tables you will get in this PPT, as well as the monogram I will give you. So this is I am skipping. Remember, when you are using this chart, you should read these precautions. There is an additional note to apply this classification system in different fields, so you need to take care of these comments. I am skipping. I have already told you. Now, they have thought of a equivalent dimension D. There is a one D correction factor, and D is correlated with the ESR, and they have found out a good curve in RQB system, and it is working. This is the correction they have in 1992 or 1994. This is the work they have done. 94. Then basically this is basically the note sheet generally being prepared for developing the classification system in the laboratory. In the field they take care of and they determine. This is already been told that why joint roughness is a very, very controversial topic in the community of this kind of classification groups. How you are considering these ripples, how you are considering the not abnormality, but what I can say, this this kind of rough surface. There is some good term I forgot. asperities. So this kind of asperities, how they are taken care of, based on that your result is depends. So they have applied differently also using the Q system. What is the roof pressure going to develop? What should be bolt length, support system? So basically this classification system will suggest you to a good confidence level how much support system you need to care of, because in tunnel and underground it is a big problem. Big problem. So without doing a exhaustive numerical model, you are going to predict the support system using this Q or RMR system, and it is matching. I am skipping. They have also tried to correlate between RMR and Q system so that a uniform approach can be come together, and it is also works up to certain limit, but not for all the cases. There are few other approaches. I am skipping. This is another GSI approach. So they have also considered geological strength index in the category of RMR, and they have come out RMR 89, and it is also matching. So see, in this GSI, with the GSI they have tried to correlate the cohesive strength or uniaxial and compressive strength of the uniaxial rock, and many teams have worked on that. Now, one application I have told you, that is the support system. Another is in tunnel, there is some gap. Even in today's modern tunnel system, TBN system, there is one time lapse, T dash suppose, in second or minutes. When it is already cut, you generally put the prefabricated lining. Nowadays it is called lining, prefabricated concrete lining, and there is some gap. So within that second of time, rock is unsupported. So how much the rock layer going to deform? So the time gap, that how much time rock will retain itself, this is basically the startup time. So the startup time is very important in tunnel excavations. This RMR and Q system have matched well for predicting the startup time, and that helps a lot for the engineers to design different categories of support system, because that amount of time you are getting, so you are in a position to accommodate within that time so that you can support your unsafe zone. This is 10 comments put by together Bunisky and Barton. These are the two big men proposed rock classification system, and these two big men have told for the engineers, for us, we are the practicing engineers, that you need to take care of these 10 parameters. So when you use our RMR and Q system, this is very, very important. So see their comments. Use the standard procedure for the measurement of the parameter instead of only description. Means they are telling that you should overcome the subjective approach. Objective approach you should take care of. Determine the range of average value of RMR and Q for their classification procedure. Not exact value they are talking about. Use RMR Q system and check them with published correlation. Means they are telling that with the large database already produced, you try to correlate. Estimate the support and rock reinforced requirement. These are the things you will go through. I am skipping. This is the two literature I found. It is one in 2007, another in 2016 or 17. These two teams are trying to fine-tune the rock classification system with the database already available, whether machine learning will help you something more to come up with a better classification system. Before proceeding to this, I want to share you some other classification system also, because that is not particularly related, but as an engineer, there are other classification systems also developed in different countries. One of the major classification system is rock slope rating. Rock slope rating. It is basically useful for the design of cut slope in rock. There are different classification system. Whether I will able to cover it or not, because lecture 3 is very big for me. That is also for overburden dams, waste dam, hazard rating system. There are other classification system also in hilly terrain, hazard slope sliding means in rocky terrain there is a frequent rock fall. So based on that observation, people have tried to classify that hazard into the classification system. So in summary, these are the approach to taking care of the actual condition, so that as an engineer we can take some action. So this approach is going to suggest you what kind of action you need to take. Okay. So basically these methods are helping you for the design of different rock structures. Forget about the limitations, though there is a large number of limitations. Even there, it is very, very helpful tool, because suppose I am not able to see something clearly, then I take care of speckles. So speckles is a tool for me to read very clearly. Maybe a good quality speckle will help you a lot, but medium range is also helping. So in that way, spirit, actually this classification system you helps up to a certain limit very, very well. So this kind of approach, when there is a large amount of complexity, scaling down the complexity into few small parameters, and based on that parameters value you try to characterize the system behavior, overall behavior. It is helping very well for that point. So that is why rock mass classification system is still today is very, very prevalent for a very jointed rock mass. So this is all. Now you are requested to ask question. Bolo.
I have a question on RMRs.
Please tell.
So you show us one slide regarding the along the dip and against the dip. Can you explain more on that? What will happen if I do against the dip and along the dip?
You tell, as you have already worked. You tell. There is a difference.
Yes, sir. So what will the difference? So we want to go.
This is basically, in initial RMR was not there. In the initial RMR system it is not there. And for your information, even this is not having any weightage. But there is a big but. So that literature I don't have now, but I can show you that people have thought of few corrections That is of the joint orientations. One of the major correction is for the rock slope. Suppose joint is not favorable for you and you have come out with the X RMR, suppose 76. Joint is very unfavorable. Then your rating would be 76 minus 60, that is only 16. So 16 RMR is a very poor category of rocks. So this approach actually come up later. I have already told you from starting from 1970 or 1965 RMR to 2014, there is a long journey of different amount of modification of the RMR system, and still it is continuing. Different team is very well contributing to the treasure house of this RMR classification system, and that is when it is work. They suggest if the joint orientation is favorably oriented, your RMR may be good. You have whatever you have calculated. But if the joint orientation is not favorable, then you need to take about some correction factor, and these are the correction factor we are proposed. And these correction factor are by magnitude are all negative. Means whatever RMR is coming, RMR dash, modified RMR is that minus that. Question? Our mining engineers? Geologist, geophysicist? No question? Then we have to move to our laboratory then. From 10:15 we have a lab to come there. Yes. Yes, that is why very site specific. Yes.
So if it changes, it's like during the is like exam, right? Like that. So in that case, normally we don't need any position phase or any difference. The composition it can change. And from a so in that case, because of the chemistry, it's like anxiety loss.
She is very fond of chemistry.
That calculate when you compare with cost of this one, it is half less higher. So it is more durable. So suppose if we are not identifying that the cost is extremely more, then when this classification is
No. Prerequisite is for classification system you have to estimate all the parameters. That is what in Barton and Uniskia they have issued a note of precaution for the engineers who will use the classification system, that the parameters being laid down in the system you have to estimate very objectively. So if you are not able to find some parameters, then you are actually missing some of the very important properties of the rock mass that may play a very important role in the overall rock mass rating system. So you have to assess first all the parameters. But the second is, even after getting all the parameters, coming out some value RMR, then they are telling calibrate with old data set. Whether with this particular site, whether this data set is very usable, useful or not. So these are the things, two things we need to keep in mind. First we have to estimate objectively the parameters. Then coming with the RMR system, RMR estimate index, we have to calibrate with the old database, whether this database is giving you a positive feedback, then yes, you can proceed. But if it is not giving some contradictory result, you have to go for a third option.
In the RSR system, usually the RQD value of the 7 but in the latest rating, these syllabus
Actually, this rock structure rating system we are no more using. So, what are the development is going on? I am not aware of it. So, I have to take care of the details. I don't know whether why they have not taken care of. Because already I have told you there are a lot of limitations of this RSR system, and it is not very much used nowadays for last 20 years in different fields. So that is why we as a mining engineer thought it is no more useful. Because we are always want to take the modern tools. Already that tool have taken care of all these errors and they have rectified. So that is why still today in our mining also in geology we are using the RMR system. So inherently actually there are some problem because they have simplified many things in the RMR system and they are not able to catch the complexity of the rock inhomogeneity. So that is why it is not played well in different complex fields or cases.